Hey, what's going on? Welcome. I am Joshua Santora, and I'm coming to you live from the Kennedy Space Center. Sort of. That's my traditional work environment, but obviously, with the state of things, I'm at home working like most of America, working like most of the agency, trying to stay busy, certainly busy putting on things like this. Glad you could join us. Today, we have a very special treat. We're going to be talking about one of NASA's treasures. This is the mobile launcher, NASA's mobile launcher. There on the top left, you can see in the distance, Launch Complex 39B. We'll talk more about that today. And then the mobile launcher on the right-hand side, a massive, literally massive, massive structure that we are going to be launching the next, NASA's next deep space rocket into orbit. And to do that, we have an expert here joining us in just a few minutes, but wanted to call attention to the fact that as we talk about the Spaceport series, we're looking at the Kennedy Space Center and the Kennedy Spaceport, as I love to affectionately call it, and specifically, we're looking at exploration ground systems today. So we're talking about EGS, as we love to call it. They're working on developing the infrastructure to launch the world's most powerful rocket. So we are super excited for that. And let me go ahead and welcome in now my very special guest. This is Cliff, let me make sure I get this right, Lanham. Cliff, how are you today?
Doing well, Josh, thanks.
Hey, thanks for joining us. Obviously, you two are not at the Space Center. You are at home working, so appreciate you joining us. I'm glad to have you on board.
Thanks, Josh. Good to be here, and hopefully I can give some people some insight on the mobile launcher.
Yeah, and as we talk today, obviously your title there, senior project manager, so a very big deal. I want to also call out, hey, feel free to shoot us questions in the chat window. Feel free to shoot us questions using the hashtag NASA at home. And so lots of opportunity there to engage with us. Please continue to do that over not only this time, but also more. Let's jump right in, Cliff. So as part of NASA's Artemis program, hopefully everyone's heard of the Artemis program. It's how we're sending the first woman and next man to the moon, and that Launch Complex 39B and mobile launcher are critical to that. So can you tell me more about what is this huge undertaking?
Sure, Josh. So the mobile launcher is the primary structural element that the rocket is actually assembled on. So essentially, the mobile launcher will be in the vehicle assembly building in High Bay 3 of that building, and then essentially gets connected up to the vehicle assembly building, and then we start stacking the rocket on the mobile launcher base. Essentially, the boosters get stacked, followed by the core stage, the upper stage, and then the Orion service module will get stacked as well. Essentially, the mobile launcher, as far as the mobile launcher and building it, just to kind of give people a feel for how big it is, basically it's almost 400 feet from the ground to the top. The base itself is 2 levels deep. It's roughly the size surface area of what you would a baseball infield, a major league baseball infield. Kind of give you some perspective there. 153 feet by 133 feet. Basically, it weighs 10.5 million pounds. The tower itself is 345 feet.
Cliff, I want to jump in there
from the
because
base.
I think you just said what I heard you just say was 10.5 million pounds. Is that a correct number?
That is a correct number, and it's a lot of steel making up the mobile launcher.
I mean, that's incredible. So ultimately, we say it's a mobile launcher, and I want people to appreciate that it's not something that you build in place. It's one thing to build something in place that's 10 million pounds. It's a whole different game to build something 10 million pounds that you move.
That's correct. Where I like the kind of analogy of it, we built a skyscraper that we were able to move around and launch a rocket from. So it's a massive structure. It's taken a while to get it built. It's very complex. That's what I always like to tell people is the technology is not off the charts, mind bending like maybe some of the spacecraft going out to Mars and all.
Sure.
But the complexity of the systems and trying to make them all work together is off the chart.
Yeah. So currently, I know we're targeting a 2021 time for our first launch of the Artemis program, which will use that mobile launcher. So thinking about that, obviously we're looking at about a year out. So where are we in the process? We've been here for years, kind of developing and getting ready. So what's the big picture timeline wise?
So let me go back for a second. I'll go back in time a little bit. So the original this mobile launcher was originally built for the Constellation program, which is going to take astronauts into low Earth orbit and ultimately to the moon. So it was a much smaller rocket than the SLS, Orion will be. So what we did was we had to go and modify the mobile launcher. And what we did, we tripled the size of the flame hull because now we have 2 boosters and a core stage with 4 engines on it within that area of the flame hull. So we had to do that. That was a single contract. And then now the contract we're currently wrapping up at this time is the ground support equipment contract. So all the ground support equipment is what's there to support and provide your commodities, your services, your power, your fuels to the rocket. There's mechanical systems that would be, on there. They would include the umbilicals, that type of stuff. Then you got the electrical systems, which would have power, instrumentation, the ground control system, and comm, which could be cameras and communications cables. There's also fluid systems. So the fluid systems would include your cryogenic fuels, your liquid oxygen, your liquid hydrogen, all flow through the umbilical, tail service mass umbilical to the rocket. So it's a lot of systems going in. Then we had to interconnect all those systems. So essentially, we had close to 5,000 cables that have to spider web their way and connect all this. We have tubing that runs everywhere on the mobile launcher. I don't even know how many miles to even quantify that, but there's miles and miles of tubing connecting all these systems together. And then there's pipe that connects the cryo systems all together. So it's a massive undertaking. We are 99.9% there. Currently, we're finishing up some structural modifications to a major truss that supports the tower, the weight of the tower, and the rocket, but it's a major truss. We found we had to go and reinforce that, so we're wrapping that up now. We're also, we found we had some corrosion on some of our fire detection system, and it's a very important system for the safety of the workers, the crew, everybody. So fire detection, we're wrapping that up as well. And then we finished up our verification and validation testing, but there were a few non-conformances, we call them, or issues with testing.
Sure.
And we're wrapping up a couple of systems that had a few problems, and so we're wrapping things up and getting ready for operation.
Man, so it's impressive just thinking about that. As you talk about like 5,000 cables, you just kind of listed off, like laundry list these systems, and I think it's easy again to kind of overlook the complexity of this. Of you have something on the order of a 32-story tall building that you're running 5,000 cables through. And kind of along those same lines, kind of just the complexity and the magnitude here, we did have a social question come in here. How do you weigh the mobile launcher? Because ultimately, like, is there a point to where, like, we're kind of guessing, like, we know it's pretty close because of the steel we're putting on it, or do we actually weigh this thing somehow?
No, we actually weigh it. So there's a couple ways we weigh it. First, the crawler transporter, which is actually the tractor, if you will, that picks up the mobile launcher and moves it from the VAB to the pad. So that has instrumentation that allows us to weigh it when it picks up the mobile launcher. And then there you see it in the video underneath the ML. And then also the support mounts at the pad and in the VAB have instrumentation on them that allow us to get the weight of the mobile launcher as well.
So again, even that requiring just some incredibly complex equipment. You can't just use your bathroom scale to go weigh a mobile launcher, which is awesome. And I'm assuming that it takes something of a small army to create this, because you kind of, again, it's a 32-story tall building that's a engineering marvel in a sense because you have all these systems integrated into it. Can you spitball me, like, how many teams are we talking? How many people are working on this?
Wow, that's a good one. So at different times, there's different types of people and different teams. So in the design and development phase, which again, we're pretty much done, it had teams for all the different systems. So there was over 40 ground support equipment systems, rattled off a couple earlier. Those systems each had teams, teams to provide analysis, design for those teams, project management for those teams. So they had teams individually, and there was overlap in the people. Some people had more than one system to work.
Sure.
So there was some of that. From a construction standpoint, JP Donovan was our main contractor, and with 5 subcontractors helping him do installing all this equipment and all this cabling. And at times they were up around 300 workers, actually out on the mobile launcher, welding, putting in cables, testing cables, putting cryo systems in. So up around 300. Now, as we transition towards operations and into operations, Jacobs, our operations contractor, they have people out there doing operations and maintenance on all these systems now. They're doing testing. They're doing the flow management, the operations management of who's doing what, because we're now into more of an operational, transitioning into that operational phase. So I couldn't hazard a guess other than at times it's probably going to be, when we're actually stacking the rocket, I would assume we're going to be in the 1,000 range. We've been at many, many hundreds at times when we were out at the park site building the mobile launcher and in the VAB testing.
Yeah, and you mentioned a really good point there about the idea of operations, and I don't want people to take that for granted. Again, so much of this is kind of putting things in context, because we've been working on the development of this for years, and then you're going to take a workforce and kind of move towards operations as we start to see hardware come in as early as this summer. There's even some pieces that are on center now, so as we move forward, what's that like for that team to kind of shake off like okay, we've designed it, now we have to go use it to fly a rocket?
Right. So what I would say is we started this transition to operations a couple years ago, actually, in essence, in trying to get the teams ready for when we hit this point in time and actually operating the system. So we were doing testing out at the park site, which is our construction area on the mobile launcher, and the operations test teams would come out and do some small, minor individual testing. As we went out to the pad and the VAB to do our multi-element verification and validation testing, which is essentially our testing that we did for SCORE against our requirements, those teams increased and they started getting more and more involved in actually performing the test, which allowed them to run their procedures, allowed them to get training on the systems, to learn the system. So now as we transition, once we returned from the pad back in December from our multi-element testing, and have declared that complete, we went into, we kind of flipped the switch as a program and went to operations. Now we have a flow manager who and his team basically integrates. It's much more highly integrated in terms of everybody's work. When we were in development, the project teams, the mobile launcher, the VAB, kind of off doing their construction and kind of managing their areas. Now we're all highly integrated. It's going into a schedule. It defines, hazardous areas, hazardous testing. Everybody can kind of now, needs to be integrated. And so that's where we're headed. And, procedurally, everything's controlled procedurally as we do our work.
Awesome. So we're about out of time for today, Cliff, but I wanted to ask you, as we get towards launch, what's going to be your role? Obviously, you've kind of been working on the project management side for getting this thing ready. And as we transition to operations, where are you going to be when we're talking about launch day? What are you going to be kind of feeling and experiencing as we near a huge milestone for NASA?
Good question. I'll go wherever they send me. But so right now I'm supporting as the as the deputy to the project management division chief. So just because we're entering operations doesn't mean the construction and the project side of the program ends. We have modifications to do to the mobile launcher to add an emergency egress system for the Artemis 2 mission when we fly crew. So there's work there. Got to go through the whole design development process there. We're also putting environmental control systems at the pad and in the VAB, new systems. So they're big projects. So there's plenty for me to do, supporting my boss in all the project management areas. And we'll keep on doing that. So once we launch, we go right back into some project development. So it's a relentless cycle that we'll be in.
Cool. Well, Cliff, it sounds like you're having fun. Appreciate you joining us tonight. and I wish you the best going forward. And I am just so excited to see this thing fly someday very soon.
Me too, and I can't wait.
All right, Cliff. Thank you.
Take it easy.
All right, so I want to transition really fast now to some current events, things that are going on. Want to make sure that you are aware that we have a great resource available, nasa.gov/NASA@home, especially if you've got kids or if you just want some entertainment in general. By all means, you are welcome to check that out. It's, again, a great space to find all sorts of cool things. I wanted to highlight a couple of those things for you right now. We have the, we'll go here first. This is the home page for NASA at nasa.gov/NASA@home. So those big tiles there leading you on to kind of some specifics. And then even more specifically, today I wanted to highlight for you the STEM at Home section, which is a really great resource for students of all ages to kind of learn things, have fun, engage with NASA missions and activities, and yeah, just a great experience, great resource available. Also wanted to call out some interesting social media activities this week, this weekend actually. So things are just moving so fast all the time. We have this one, which is a great example of kind of this planning happening as we proceed. We're moving at an incredible rate. So excited to be able to share this past week. This is the plan leading to our understanding and of what we're planning to do for the moon and going to Mars after we're done with the moon, or as we master the moon, so to speak. So we're not just going for a short trip to the moon. We want a sustainable presence. We're saying 2024, we want boots on the moon. 2028 is a sustainable presence, and that's with Mars, our eyes towards Mars. And so that's what this is about, looking ahead towards Mars and laying out this roadmap for us for the future. Also, another great highlight, Mars 2020, also named Perseverance. Super excited about that. There's actually this really cool thing happening where we're sending up almost 11 million names of people that will be going on board this chip here, this plate, that will be going to Mars. So this rover is getting ready for launch in July, and they'll be taking this up to on board an Atlas V to launch this summer, all the way to Mars. And then just released this afternoon some really cool imagery of an emergency egress test that was done for SpaceX as a part of the commercial crew program. Essentially, this is working through the process of if there's a bad day at the launch pad, how do we know that our crew can get out safely? And so they ran an end-to-end test, basically from the top of the tower down to the ground and away from the launch pad to safety. So really, really cool kind of experience there. Definitely be sure to check that out. Check out all of our social media online. There's so much going on. Want to also make sure that I plug the nasa.gov/EGS. That's where Cliff works, the Exploration Ground Systems. Appreciate all their hard work getting ready for Artemis. A ton to look at on nasa.gov in general, but that is going to do it for me tonight. I wish you all the best. Be safe, stay healthy, and remember, even the sky isn't the limit. Have a good night.